Aloha and welcome. We're continuing down the road of application attacks. And in this one, we're going to talk about race conditions and resource exhaustion. So race conditions, it's kind of a misnomer. I always, when I hear race condition, I think of a foot race. And in a way, you can look at it that way, but the way it's often described is nothing so exciting. So a race condition is a software event in which multiply concurrent executing processes access a shared resource at the same time. We talk about the target of evaluation, and that's the shared resource that's being accessed. That can be a file, it can be a memory location, or a program variable. Any multi-threaded program and programs that run on multi-core CPUs, they can be impacted by a race condition since multiple processes execute concurrently being at the same time. So the time of check to time of use, or TOCTOU, is a class of software errors that are caused by a race condition. So the time of check is when when the process checks the TOE's state. In other words, it's when it checks that variable or the file or whatever it is, it checks the state. And then the time of use is the time in which it processes, something using that target, variable or file or whatever it was. So a TOCTOU error is going to occur when the state changes between the time of check and the time of use. So if you go and you check something, let's say you're let's say you're running a program and you wanted to say, okay, what's the value of X? So you say, okay, let me check. Let's say you're doing an if check or something, and if X is greater than something, you're going to do something. So let's say you do a check on X and it's above your threshold. So you're going to do something. But then, while you're about to do something else, a concurrently running thread changes the value of X. And now you're no longer in that range. So you really don't want to be doing that, but you go and you run that thing. That's a TOCTOU error. That's the time of use to time of check, or time of check to time of use error, because you wouldn't have wanted to, but something has changed between the time of check and the time of use that has modified the state that you're in. So you're in a state that you didn't expect. That's one way of looking at it. Another one is you have what I look at is the race condition is often when you have two processes that are maybe using some of the same variables between them. You may change the value of X, but then the other process may change the value of X as well. And if you're both messing with it, then the end value, you may have thought that you were, let's say you're editing a file, you thought you edited it to be this, but then the other one went and overwrote those changes. So same thing for variables, you can overwrite values of one on the other. So if you're in the middle of doing processing, let's say you're in this 1,000 lines of code over here and you're in 1,000 lines of code over there, and you change the value of some similar things in both of them, you may totally screw up the interactions of your programs. You may be, if you're overwriting the value, that memory value for X over here, and it's using it over here, then you're going to get unexpected results in both threads, most probably. So that's what we call a race condition. It's the race to see who modifies it last. So so that's something to keep in mind. You need to really be careful of race conditions. The other thing that we talk about is resource exhaustion. We've talked about resource exhaustion before. It's also known as a resource starvation attack. This is when it's an attack where the aim is to slow down or disable an application by using up all the application's limited resources. We've talked about it when we were talking about routers, and routers have tables, and the idea is that you try to overwhelm it and use up all its resources, and then it can't accept anything else. That's one idea of an resource exhaustion attack. Another one is going to be a memory leak. So if you have a program that has shoddy memory allocation and deallocation, let's say the programmer forgot to deallocate memory and an attacker discovers that, they can just go and try to exploit that to overwhelm the thing, to bring it down, or to make it behave in a way that it wasn't supposed to behave. So these are it can be denial of service attack, but it can also be, attack where you're trying to modify the behavior of it as well. But certainly you can overload it and exhaust it of resources and bring the whole application down. If it's a distributed application, then you bring it down for everybody. So That's the things to worry about. That's what we cover in this section. And that's it. We've just got race conditions, remembering that, if we're running concurrent threads and we're modifying some of the same variables, you have time of check to time of use competition there. You can have errors that come about because of that. And you have resource exhaustion attacks where you're exploiting something like for the MAC tables, there were problems with MAC tables, but over here with memory leaks, you could be filling up memory just by doing certain things that are going to have it fill up memory until it just pops and breaks. So yeah, be careful of these. And if you have any questions, reach out and I'll be happy to answer. Aloha.